Hello, welcome to the session on measurement of temperature. In this session, we will focus on resistance temperature detectors, thermistors and thermometer. RTD or resistance temperature detector works on the principle that resistivity of metals is highly dependent on temperature. In fact, if you increase the temperature, resistivity also increases. RTD is a temperature measuring device composed of resistance thermometer element, internal connecting wires and a protective shell. Resistance thermometer with metallic conductor is known as RTD or resistance temperature detector, whereas the resistance thermometer that uses semiconductor element, resistor element, semiconductor measuring element is known as thermistor. The working of RTD is very simple. RTD element or the resistor is placed in the proximity of the area of interest where temperature is to be measured. A current is passed through the element. Value of the resistance of RTD element is measured. The resistance value is correlated to temperature using resistance temperature characteristics of the material of the element. Several metals are used as resistor elements. Examples include platinum, nickel and copper. Platinum is very popular among these metals. What are the desirable characteristics of RTD elements? RTD element metal should be sufficiently ductile. Wire forming should be possible. It should have linear temperature resistance relationship. It should be resistant to corrosion. It should not be affected by the environmental conditions. It is inexpensive. It should be inexpensive. This condition is difficult to meet in case of platinum since it is one of the costliest metals. It should be stable and sensitive as well. It should be able to measure small temperature variations as well. It should produce reproducible results. It should give reproducible results. Platinum is very popular as RTD resistor element. What are the advantages? It is chemically inert. Its chemical inertness is great. It has almost linear temperature resistance relationship. It also has large temperature coefficient of resistance which enables to measure small variations in temperature. It is stable over a long period of time. There are three common configurations of RTD. First one is partially supported wound element in which a small coil of wire is inserted into a hole in a ceramic insulator. Second one is wire wound RTD in which a platinum wire or any other metallic wire wound on a glass or ceramic bobbin. The setup is sealed with a coating of molten glass. Thin film RTD, the third type, where deposition of platinum glass slurry film is done on a flat ceramic substrate. Schematically we show wire wound RTD and thin film RTD. Here you can see there is a ceramic bobbin, around that wire is wound. Then entire this setup is placed in a molten glass, then it is solidified. So it is a rigid RTD setup. So this is the thin film where ceramic substrate is taken and metal ceramic slurry is deposited on this. What are the merits and demerits of RTDs? RTDs generally have almost linear temperature resistance characteristics. They have greater accuracy in the order of plus or minus 0.1 degree centigrade. It is easier to replace, so maintenance of RTD is easier. They have a wide working range without losing much accuracy. Further, they are stable over long durations. So long exposures, they give stable readings. Multiple resistance elements also can be used in the RTD setups. There are several disadvantages. First one and the most important one is use of platinum makes the setup costly. Sensitivity is lower than thermistors, although it is better than thermocouples, but compared to thermistors, its sensitivity is lower. Now we will see what the thermistor is. Thermistors are those resistance temperature measuring devices which use semiconductors. So semiconductors that are used as temperature measuring elements are known as thermistors. What is the principle? Resistance of a semiconductor decreases with the increase in temperature. You may notice the difference with the principle used in RTDs. Resistance of the metal increases with the increase in temperature, whereas resistance of a semiconductor decreases with the increase in temperature. Commonly used thermistors: germanium with small quantities of arsenic, gallium, antimony. Then the other possibilities are metal oxides. Oxides of manganese, nickel, cobalt, iron, copper, zinc. Several possibilities are there. The temperature range of thermistors, it is from minus 250 degree centigrade to 650 degree centigrade. If you look at the advantages and disadvantages of thermistors, thermistors have very high sensitivity. They are able to measure very small temperature change. If you notice here, a small temperature change provides a large variation in the resistance value, hence the flow of current. You can compare the behavior of thermistor with that of RTD as well as thermocouples. So on the basis of sensitivity, thermistors are very highly sensitive. So next comes RTD, next comes thermocouple. The response time is short, quick response. They can be used for precise temperature controls since the response time is small. They are not very expensive. However, there are some disadvantages. Compared to many others, like specifically RTDs and all, their temperature resistance characteristics are non-linear. Therefore, careful calibration is required. Then temperature range is narrow compared to other. So here you can see temperature range is narrow. They are not so stable with time. Like RTD or thermocouples, they are not very stable with respect to time. So if you expose it for a long period, it may give rise to errors. So there are chances of self-heating errors as well. So it is closely related with the earlier disadvantage. Now we will move on to thermometers. They are the popular temperature measuring devices. They are simple, inexpensive, easy to use and maintain. Common types are liquid in glass thermometers, pressure thermometers, and bimetallic strip thermometers. So liquid in glass thermometers. So the sketch shows the common thermometer which we use in our day-to-day life. They are most popular and widely used temperature measuring instrument. There is a temperature sensing liquid used. Mostly it is mercury, but other possibilities, other choices are also there. Alcohol and pentane also can be used. Small volume of sensing liquid if you use, it gives quick response. However, sensitivity will be less. Whereas if you use large volume, sensitivity will be better, but response time is more. So liquid in glass thermometers are simple, portable, inexpensive. However, disadvantages, they are fragile, requires calibration, not suitable for remote applications. Pressure thermometers are used for measuring the change in temperatures. The pressure and volume change with the temperature variation is the principle. So that means any fluid if you take, if you change the temperature, its pressure and volume changes. In other words, fluid expands or contracts with change in temperature. This is used in pressure thermometers. So pressure thermometers also have several merits and demerits. So direct recording is possible. They are less expensive than other systems. Further, they are superior. They provide superior dynamic response and maintenance is also easy. On the other hand, their linearity is limited. They are prone to output errors. Pressure differences, elevation differences, fluid properties affect the output. The diagram shows the pressure thermometer where a bulb filled with the liquid or any fluid, gas or combination of those, then there is a flexible capillary tube and a Bourdon gauge. Fluid expands or contracts with the temperature variation. Accordingly, Bourdon tube moves or uncoils. This is how reading is shown. Needle on the scale is actuated. So when the Bourdon gauge moves, needle also moves. The last type of thermometer what we deal today is bimetallic strip thermometer. It is based on the principle that different metals expand or contract to different extent with the temperature variation. So it is based on the respective materials temperature coefficient of resistance. So if you see in this diagram, metal strip A, metal strip B, they are rigidly connected. Now if you change the temperature, they expand to different extent. Therefore, either they bend to one direction, otherwise they bend to other direction. So if in the cold condition, if they bend to left, then when it is heated, they will bend to right. So this is due to the differential expansion of constituent strips. See, two different metal strips are used, both expand or contract to a different extent. This is the principle of bimetallic strip thermometers. They are used in hot water pipes, steam chambers and clocks. To summarize, we have seen that RTDs and thermometers rely on changes in resistance with the temperature variations. RTDs use metallic resistor elements while thermistors use semiconductor elements. Thermometers generally use a sensing liquid which expands or contracts with the temperature variations. Bimetallic strip thermometers use two different metals or alloys whose temperature coefficient of resistance values are